Breaking the Wall of Huntington's Incurability. Deepshika Arasu, Falling Walls Lab, Paris.
You're 30 years old. You start noticing some strange things. Small, involuntary moments, bouts of irritability, and moments when your thoughts just seem clouded. At first, you brush it off as adult sleepless nights, but something tells you to go see the doctor, and that's when your world turns upside down. You're diagnosed with Huntington's disease, a devastating neurological disorder that affects 5 in 100,000 people worldwide. This disease does not discriminate. It doesn't see gender, color, or ethnicity. And the worst reality of it all, there is no cure. Huntington's disease is caused by a genetic mutation that affects a protein. This leads to the death of neurons in a part of the brain that's critical for movement, coordination, and much more. Previous attempts to address this by injecting fetal brain cells showed some promise, but these were not consistent or reproducible. Imagine injecting fetal brain cells is like drawing a circle by dipping your fingers in ink. But what if you wanted the perfect circle and you wanted to repeat it 10,000 times? Would you still be using your fingers, or would you switch to a reliable printer with some ink and paper? Luckily for us, we have a bioprinter for creating this replacement brain tissue. Most people, when they think of bioprinting, they think of a needle depositing layers of cells and biomaterials. But what I do, I use Poietis' laser-assisted bioprinting. The laser sounds cool, right? It is. It is a great fit for our cell types, and these gentle lasers do not harm our cells. And further, when we think about the ink, you're also thinking about some kind of cells and biomaterials. But I use mini aggregates of few thousands of cells called organoids. Organoids are great at mimicking the brain tissue composition. So what about the paper? Our goal is to create a construct that seamlessly integrates into the brain. To do this, we must be able to stimulate and mature the neurons. And by using a scaffold guide as a paper, we are able to achieve this. The automated bioprinting platform provides an opportunity to scale up and reproducibly create this engineered brain tissue, which can be transplanted into the brains of Huntington's disease patients and save their lives. We have a team from all around Europe, and we are confident in breaking the wall of Huntington's disease.